Okay, I think we're all set. So thanks for coming again. It's such a pleasure to be here with this dedicated group of folks and a nice small group so we can hopefully chat a lot today. I know last time there was a lot of info that we were looking at and we didn't have as much time maybe to talk. So we'll try to incorporate that today. Okay. So just as a reminder, I'm Erin from the Washington, D.C. area. And something I just wanted to share with you today, I'm really itching to be back with students and teachers in person again. This is a picture of me in a seventh grade class that I taught several years ago, being silly before winter break. And I like this picture because it just reminds me how fun it is to be with students in person and really those off moments where you're not doing math and you're able to connect with them as people. So I'm really looking forward to that in the upcoming weeks and the rest of the year. So before we start, you guys are great at doing this. Feel free to chat a question. I'll try to monitor that. And then the recorded session is available at that link, which I can share if that would be helpful. Do you all have that link or do you want me to share it? You have it? Okay. All right, great. So this is the website where it will be available, the recordings. Okay, so everyone has the note catcher. We're all set. Okay. And the Zoom norms, this is our fourth time, so we are all good on that too. So let's keep it moving. Let's start out today with a little reflection to launch our work. I know that in a previous session, we talked a little bit about our math identities as a math learner or as a teacher. So I want you to think today, springtime, if math were the weather, it would be which of these and why? So whenever whenever you have an answer, go ahead and chat it. You might say, it's the clouds, because when you're stuck on a problem, you feel gloomy, but then you figure it out and the clouds clear. But which one resonates with you? That's great. Thanks. Megan said it reminds her of the tornado because we need to continually spiral review to build math concepts. That's great. We'll talk a little bit about that today. And Tara, the ice. I was hoping someone would pick the ice because that one resonates with me. It's like you feel a little icy. You're not sure. Students are a little trepid about it, but then they can get it. Oh, good. Makes Brenda happy. Yes, math is beautiful, and hopefully the students can see that too. Awesome. Anyone else want to share? All right, well, we started with this today because we know, as we've discussed before, that, by the time students are in second grade, they might have already developed a math identity. And for some students, this could be less than positive. And we know that as they feel that way, they can feel anxiety. And so we want to uncover and nurture that positive math identity for students. And so we want to give them those positive experiences and help them feel confident to be successful in math. So now that we've kind of grounded ourselves in thinking about what math can feel like, let's chat a little bit about, and you can unmute for this. Unless you prefer to type, it's totally up to you, but I'd love to just hear what's been happening since our last session. I know that many of you have shared that you're kind of using these as a lens to think about next year, but maybe there are some things you've implemented or things you've just been thinking about or talking about in your school teams. So what have you done to or thought about to support delivering those just-in-time acceleration supports that we've been talking about? And if you have implemented some of them, are there some things you learned? What might you do differently? Basically, anything you're willing to share with the group about small nuggets of progress that you've been making. And we have about 5 minutes for this. So if you want to take a moment to get your thoughts together, you can jot it in the note catcher, you can jot it in a notebook, or you can just start to share when you're ready.
I had one thing that we tried at Clinton with our 4th grade team. We discovered in our math expressions curriculum that there is a prerequisite skills assessment that goes with each grade level. So in 4th grade, we looked at the prerequisite skills from 3rd grade and chose 5 questions from that assessment based on fractions and decimals. That was the unit they were getting ready to teach. And so we gave students that assessment. Teachers took that data snapshot similar to what we looked at with that 4th grade team, and they found that many of the students were not there yet, which was super important for them to realize going into teaching 4th grade fractions and decimals that kids didn't know that what fractions were equal to a half, or how to compare 2 fractions with a common denominator, or one of the other skills on there was just locating a fraction on a number line between 0 and 1 whole. So what we did, after realizing that most of the kids were not there yet, is that we added to their already existing math warm-up routine problems based on the 3rd grade unfinished learning. They're in the process in the 2nd week of doing that math warm-up, and then they'll be getting ready to assess Unit 7 at the beginning of next week. So we're hoping that all of that work is going to pay off when they give the kids the assessment. And we may even, I don't know if it's worth it or not worth it, to go back and give that same assessment with the 3rd grade skills again, just to see, did they finish up that learning from 3rd grade with the process of their warm-ups.
Nice work.
Thank you. We were pretty excited about it. And the team was totally on board. I said, can I just try something that I'm learning with you? They were totally on board. We're just hoping we can get that to spread to other grade level teams.
Great. Thanks for just digging in and trying that. And thanks for sharing all of that with us. That's great.
It was fun. They loved it.
Yes. Oh, good. I'm glad. And so something that resonated with me was that the choosing those 5 questions, like, was the assessment as it was it a lot longer? And so the 5 helped it feel more manageable to dive in?
Yes. So the assessment itself, I don't even know how many questions it is. It's pretty long, but it's divided into categories.
Mm-hmm.
We went right to the section that was fractions and decimals. Mm-hmm. And then we really looked to see which of those questions most closely matched what students would be asked to do in Unit 7. Mm-hmm. So we looked at the Unit 7 assessment, compared it to what we saw in 3rd grade prerequisite skills, and they chose the 5 questions, which I thought was important. I could have chosen them for them, and they actually ended up choosing the ones that I probably would have chosen myself. So, but it was their ownership. So it was worth it for them.
Wow, great. You could be the case study next. That's great. That's great.
Thank you.
Yeah, and it sounds like you really use that understand piece to get them to understand, like, where are the students going. And I know that we've heard this before, that, folks on this call, like, the backwards planning is so important. And so getting them to understand where are they going in 4th grade is helpful to know, what do we need to diagnose from 3rd grade. Thanks so much for sharing. Would anyone else be willing to share what you might have been thinking about, or what went well, what might you want to do differently?
I think the biggest thing that we talked a little bit about, and we haven't done a whole lot with it, but it sure is on our radar as we think about next year and just looking at that long range planning and scheduling, is we've tried to, we had the, I guess, luxury of hiring a math interventionist this 2nd semester. And she's been trying to work a couple days ahead of the classroom teacher to pre-teach some skills. Mm-hmm. And after last time looking at that case study, they worked a couple weeks ahead of the classroom teacher. And that made so much sense, because lots of times if kids are behind, they may not pick it up in just 1 or 2 sessions. And so we are going to try to be really intentional with just the calendar and the planning and trying to stay ahead of that. And I think we talked about it last time. It just seems to get away with from us. Like, we have best intentions, and then so we're gonna try to stay on top of that again. Just always being really cognizant of that, and how do we plan that so that we're we're giving kids a little bit of leeway
Mhm.
and a little bit of run time before they actually start that unit in math. So
Oh, wow, that sounds great. And to be cognizant of that. I know it's always the time thing is always so hard, but it's nice that you're seeing that success, giving them that runway to practice those skills so that they can be ready for the tier one in class instruction. That's great. All right. Thanks for sharing. Any other thoughts before we keep moving today? Okay, well, hopefully we'll have lots of chances to share. So I appreciate all of those. So in our previous sessions, just as a reminder, we looked at planning and taking action to address unfinished learning in the whole group and small group instruction. Today, we're going to dive into planning and taking action to address unfinished learning with more intensive small groups and individual interventions. So those students who are maybe not responding to some of those tier one practices. I want to frame that understanding diagnose piece that we talked about in the other sessions is still really important when you're implementing interventions. But today we're really going to focus on the plan and take action piece. Okay, especially that diagnose piece. We want to have the progress monitoring in place to know who really needs this interventions. And I'm sure you all already have, experience with this, but we'll look today at some of those best practices for planning and taking action for those students who need a little bit more. So why intensive intervention as our last session? So this is a graph of some longitudinal studies. So they followed students across years, their performance across multiple years. So the horizontal axis is the year in school where the students first started the study. And then, the different researchers are on the left-hand side. And so, the one study towards the top, it has this long bar, they followed students from pre-K to 10, and they noticed that their performance in pre-K was related to their performance in 10th grade. Okay, I don't think we're super surprised at some of these. This other one looked at, they started in grade 1 and it was very predictive for performance in grade 3, 5, and 10. And then this one here, they looked at grade 8 math completion, grade 8 math performance, and then tried to see if it predicted for your college performance. And in fact, it did. And so all this to say that if we know students' early math performance can predict future performance, we want to support students as soon as possible that are struggling, right? And so the research also shows us that we can do that, right? When you intervene, we can improve students' long-term learning trajectories. So effective interventions can improve those outcomes. And so the question now is like, how do we do that, right? Because students are diverse learners. And so today is intended to be a beginning point for us to have this conversation, not an end. So it's really just the beginning of thinking about what are those practices. And I will say that you'll see some overlap between the idea of acceleration to get students ready for on grade level and then these more intensive interventions. These are best practices for students generally. So I think you'll be able to apply them across different settings. Okay, so we're going to spend about the first 45 minutes here looking at 3 of the practice recommendations for math intervention. Then we'll spend almost the last 25 minutes talking about fluency specifically. And then finally, I'm really going to try to get us to have at least 10 minutes for wrap up because I think that would be nice to kind of tie a bow on our 4 sessions to have the last 10 minutes to talk about what we're thinking about for the future. So I may go a little faster in the middle just to get us that time. Okay, here are 3 goals for today. Let me give you 30 seconds to read those. Okay. So let's dive in here. So up till now, we've really talked about that whole group instruction and then maybe small group instruction. And as I mentioned, we're going to consider some practices for individual interventions for students who may continue to struggle. So the multi-tiered systems of support, obviously start with that core instruction, the high quality curriculum. And then we focus the last 3 sessions on the middle section, that acceleration support. So giving timely and curriculum embedded support to students to be successful with that on grade level material. And so today, when we talk about interventions, we're talking about even smaller groups or maybe individualized instruction designed to target specific skills using evidence-based still, high quality materials still, and strategies. So we're going to talk a lot about like, what does that mean, strategies, and then including assessments to monitor student progress. So for students, this is again, those students who are maybe not responding to the acceleration approach. So it should be this, hopefully a small portion of the students that will need this intervention. I think sometimes, myself included, it can feel a little overwhelming to think, okay, I've got the tier 1, I've got to do the acceleration support and then this on top. But, hopefully this is a small group of students. And, I think it's great, Jennifer, that you were able to onboard that math interventionist. And so, be thinking about how we can use different folks at the school to support students. So it could be learning interventionists, it could be a learning specialist, it could be in part of the math classroom. So the idea is that this is for that smaller group of students that needs that intensive intervention. And as you all know by now with your experience in schools, there's obviously no magic bullet, right? So like interventions are something you do, it's not necessarily something you buy. So there are obviously evidence-based computer programs and there's specific intervention curriculum that can and should be utilized to support, but there's no perfect intervention that's going to be a magic bullet to meet all students' needs. So the focus today is not on like the specific platforms, but rather on the research recommendations for how to implement instruction. And you can use these ideas if you are evaluating, for example, an intervention curriculum that you might implement. You could use these ideas to think about, like, what does that look like? I also want to say that there's just, I think around this, there's a lot of questions and maybe less research and less implementation than we've done at tier 1 level, like the core instruction. And so you may have lots of questions. So at the very end of your note catcher on page 16, there's some FAQs for intervention if you're interested in looking at those. And those will be there for you. Okay, so as a starting point, I want to frame that we want these things to be in place before we dive into delivering the instruction. So the first is that we want to have some assessment to identify students' learning needs. And so there should be some universal screeners in place. But in addition to that, you want to have the diagnostic screeners, things like the curriculum embedded that you were talking about, maybe some interviews and then observations for students who you think might need the more intensive intervention. So we want to have that assessment in place so we're making evidence-based decisions like we talked about last time. The second thing is that we want to make sure when we're thinking about intervention that we're focused on that most important major work, right? It might seem logical, and I've done this. I give the map test to my students and their weakest level of performance, I go for that and think, oh, we need to review that. But that might not be the best strategy for them long term. We need to make sure that the time we're spending with students, because our time is our limited resource, right? The time we're spending is on those most important instructional areas, like those high leverage areas. And so I think it was in session 2 where we talked about the NDE essential instructional content document, and then the student achievement partners essential instructional content, it's a lot, documents. So those can help guide our work with knowing like what is that major work of the grade. Research also highlight, and you'll see this matches and mirrors those other documents, that in K5, it's really properties of whole numbers and operations that should be the focus. And then 4 through 8, unsurprising, work with rational numbers. So like fractions, we know that predicts later math performance, and advanced whole number arithmetic. So these are those really important areas for students and their future math performance. Hi, Ryan, welcome. I'm just going to drop the note catcher link for you.
Thank you.
Okay. And so the last starting point is that, we want to have some time where this can be addressed. And I think this might be where we have a lot of the thoughts, is where could that be? So because we want to do this consistently for students, like the acceleration support, we want to have designated time for it. So it could be done inside the regular math block. If you have 90 or 120-minute math blocks, you could say the first 30 minutes is for this. You also may have intervention time outside of the core math blocks, like if you had that as part of your schedule, and if you had an interventionist. So, you know, with that in mind, you just want to make sure you know, when is this going to happen? So those three things we kind of want to have in place before we think about how do we deliver that instruction. Does anyone have any questions about those three? Okay. All right, so let's look at the actual recommendations. And this study just came out this spring from the Institute for Educational Sciences. They released 6 practice recommendations for effective approaches to math instruction to meet the needs of students in the small group or the one-on-one settings. Let me give you a minute to read these here. They're also listed on page 2 of your note catcher, so you'll have those for after this. So take a moment to read these. So what they found was that each of these practices moves students towards a more fluent performance of math. And so we're actually going to have time today to look at 1, 2, 3, and 6. If you would like to read about 4 and 5, they are in that guide. And it's a rich document. So you can feel free to check that out. But again, today we're really going to focus on 1, 2, 3, and 6. Okay. So the first recommendation is to provide systematic instruction during intervention to develop student understanding of mathematical ideas. So I'd love to hear just sort of your initial reactions to this. Like, what do you think about when you think about systematic instruction? What stands out to you about this recommendation? And you can feel free to unmute or chat, your choice. Any initial thoughts on the first recommendation? I mean, I think one of the first things I thought about was, okay, the idea here is that we're developing student understanding of mathematical ideas, right? And so let's dive into that and see what is systematic instruction, and then how do we use that to develop ideas? So it's not just about skills, it's about building those ideas for students. Okay. So systematic instruction is curricular materials and instruction designed to develop those concepts and skills in an incremental or intentional way. So that's what sort of makes it systematic. And we'll see an example in just a moment. It's connected to the learning progressions. I know we've talked about that before, kind of seeing how the standards build. And then it intentionally builds student knowledge over time towards some desired outcome. So we have to know where we're going, and then we build students up from there. This is not, it's not systematic in that it's direct instruction. It's not I do, we do, you do. It's not isolated drills, like we probably remember those from school, drills and worksheets. And it's not teaching skills in isolation for a meaningful contest. So this is very much related to what we talked about last time with the acceleration approach, that you want to be building those ideas. Okay. And why is this important? I'd like if you can see this. Are you able to see this graph of the trends in 4th grade NAEP scores? Okay. I want you to try to notice what's happening here from 2009 to 2019. What do you see is sort of happening to the NAEP scores? On the right is the key of the percentile for the students who took the test, but then on the left scale score is their scale score, and it's also written on the graph. So what are some things you notice about the NAEP trends? I know it might be harder to see on the small screen, but if we focus on the students in the lower percentiles here, the 25th and 10th percentiles, we actually noticed from 2009 to 2019, it looks like that their scaled scores are actually decreasing a little bit, right? The students in the upper percentiles, they're increasing. So, this says to me that, we want to catch up, the progress we've made in tier 1 instruction with these, with newer standards and the focus in tier 1 and whole group instruction on conceptual understanding. We want to catch up for those students who are performing at the lower levels. And why might this be that they're not doing so well? Well, several studies revealed that this tier 2 instruction for elementary middle grades consisted largely of worksheets. So unfortunately, we need to catch up and get that work with ideas in front of students versus worksheets. Does anyone have any thoughts or reflections they want to share? Do you see that in your school maybe, or have you seen that in the past? Yeah, we know that high quality curricular materials are that cornerstone of the core instruction because they're designed to connect the learning. And so we want to make sure that's true for intervention as well. So let's take a look now at a vignette. This is on page 3 through 8. So I know it sounds like a lot of pages, but it's dialogue back and forth. So you'll take 5 minutes to look at this. And as you review, please note what you notice about the questions. So that progression and the systematic approach, the questions, and then how does that sequence of questions support the student with making sense of the math they're doing? Okay, so 5 minutes. It's pages 3 through 5, 3 through 8. Two more minutes and we'll come back and share. Okay, whenever you're ready, go ahead and unmute. And let's share what you noticed about the questions and the tasks in this example. Anything you noticed? Hope everyone's still on mute. Are you still thinking?
Well, I think it was made in real world context. So they were talking about donuts, they were talking about strategies, they were being very specific. Feedback was provided so that the student understood exactly what they were doing well. And then questions came to be when it was guiding to where you needed them to be, or another strategy, or to better develop the strategy they're using to understand and get the student to where you want them to be.
Thanks, Tara. She highlighted a lot of important things. Those grounded in that real world context to make some meaning for students. There was communication and feedback back and forth so that the students could understand what they were doing well, maybe some refining of language, and then to get them where they needed to be. Great. Any other noticings?
Just kind of piggybacking off of what Tara said, is just that she really like drew the attention of what was she doing well, and how can she continue to apply those concepts and strategies into the harder, like with the double digit problem. So I kind of like that, where she was really just making sure that's like kind of doing almost like a think aloud with her, like, okay, what did you do and how was that successful for you, and how can you apply this strategy, so that she's really almost like just being that facilitator for her and coach on the side, so that she can kind of get there on her own.
Great, thanks, Megan. And you highlighted a lot of important things like that positive reinforcement, starting with what student knew. So she was doing this, helping give some language to what the student was doing, and then you really hit that we're building up to this new skill of dividing by two-digit divisors. So starting with something the student was comfortable with, getting them to communicate and think, and then really drawing up that. Great, thanks.
I was just going to say also just the amount of she forced her kind of to put in the academic vocabulary, where she talked about like the answer and she says product and one of those numbers, the factors and commutative properties. So just having her use that academic language, which I also think builds that understanding better for the students.
Yes, exactly. Thanks for pointing that out. And that's the next recommendation we're going to talk about. Janine said something really important here, that using the language isn't just for using the language, it's for building that understanding. Like that helps them build the understanding. So that's great. So you all really noticed that. That's great. They used something else I just want to highlight, that using accessible numbers to the student. So like when you're introducing this new concept or these new methods, using something that is comfortable so they can build up to that skill. And it was really purposeful sequence, right? Like starting, as you mentioned, with the donuts and the multiplication, the group sub, to then show how you can use that for division. So great. Thank you for sharing all those noticings. And so, as you mentioned, you guys really hit on these, that how do we carry out this recommendation? So first, integrating that previous content, as you mentioned, making sure it's connected, using numbers that students are comfortable with when introducing this new concept or procedure, and then giving that feedback that you mentioned, addressing those misunderstandings in the moment to get them constantly building their understanding. So nice noticings. You guys are well on your way to supporting teachers to do this. Okay, so now let's take a look at the second recommendation, which is using clear and accurate language, which is what Janine just mentioned. Okay, so take a moment to reread this recommendation. So as we alluded to just a minute ago, it goes deeper than just teaching the math vocabulary. And so we're going to take a look on the next slide. Before I show it, I want to preface it that I've said some of these things, and you know, as we progress in our understanding and our learning, we see why they can be problematic. I think sometimes in the moment, as we've mentioned, with students who struggle, we want to sometimes give them the easiest way or the shortest way. We just want to help them be successful. And when we look at the words on the next screen, I want you to think about, even if you've said them like I have, just why that may or might not develop their understanding. Okay, so I'll reveal them now and then you can take a minute to read these two things. So what do you notice? Why might using this language with students be problematic?
I don't notice any discussion of place value. If I cannot subtract my ones, I need to ungroup some tens, or when I'm dividing, do I have enough hundreds to divide into 5 equal groups? So when I'm teaching that, I would want to be sure to mention the place value so students understand if I don't have enough of one place value, I need to go to the next place value.
Exactly. So this, you know, this is a digits approach, and that's not building that conceptual understanding of place value, which is so fundamental for computation and understanding of the mathematics. So, you know, beyond just, you know, wanting to teach students vocabulary so they can communicate, it's that we need to use this vocabulary so they can actually understand the concepts. You know, when we don't use that precise language, they could misunderstand something, or you know, they might just memorize the steps instead of really processing what's happening. So thanks. So let's take a look now at what it might look like to use some more precise language when working with students in an intervention. So this is on page 10, and let's take 2 minutes to read that on page 10. Okay, hopefully that was enough time. Let's focus on question 2 on the screen. How does using the terminology support the students in making sense of that algorithm? So again, we're not just using the terminology to use it, it's to help students make sense of what they're doing. So what did you notice there?
I noticed that, sorry, Janine, geez. As the teacher kind of rephrased what Carrie was saying, using that mathematical language and explaining what she was thinking, then Carrie started to use that as their conversation continued, which just shows that her thinking was progressing, and she was really building that understanding of the mathematical concepts that she was using. So
Great. Yes. So seeing that student then adopt that language is helping them internalize the concept. Great. Mhm. And I think probably because you all are educators, it's really obvious to you, but that, this language supports students understanding the value of each digit. You know, what Brenda was saying earlier about this place value, that like this idea of regrouping rather than borrowing, it's helping them process what's happening, right? Great. So tips to carry out this recommendation using the clear and concise language. So, routinely building in that vocabulary to help build their understanding of the math. Use it. Use clear, correct, concise, and correct to reinforce students' understanding. And then support students. So like support them in using it, as we noticed here, like getting the students to use it themselves. There are some tips on page 11, if you would like those, for carrying out using precise mathematical language. And you've probably heard these before, but there is a little table on that page that's nice. It says rather than using this term, use this term. So like rather than using borrowing or carrying, we would use regrouping. Just these small changes that can really make a difference in students' conceptual understanding. And you probably, know that we don't want to say things that expire. Like you can't take 8 from 3 because we know starting in 7th grade you can. Negative numbers. So. Okay, let's move on to the third recommendation, which is multiple representations. So the idea is to use a well-chosen set of concrete, so physical, manipulative, semi-concrete, those 2D drawings. Use those to support students' learning of the procedures and concepts. And we want to make the math visible and accessible to students in intervention instruction. All students need this, but especially our students who might need extra support. We talked about this last time, I think a little bit, that one of the recommendations and principles to actions is using and connecting representations. So if you look at what's on the screen, the idea is you might start with those physical manipulatives, then students might draw arrays. But the really, really important part is that you connect that array to the abstract equation. Like students have to see how they're related. Like we don't want to do one day of manipulative, one day of arrays, and then one day of the equations, but never show them why they're related and why they can be helpful to one another. So let's kind of start with that in mind. And, this semi-concrete are all those things we've talked about: strip diagrams, tape diagrams, tables, graphs, number lines, so to help them visualize, okay? This helps students, like obviously, give them a way to communicate their thinking, but also supports the understanding. So like the vocabulary, you can tell them that these are square numbers, for example, 1, 4, 9, we've all learned that at some point. But if they can see that the reason they're a square number is because it's 2 times 2 and 3 times 3, it can help them build that conceptual understanding even better. Okay, so for this recommendation, we're actually going to watch a video. So instead of reading a vignette, we're going to watch a video example of a place value representation being used in a virtual intervention setting. So the teacher teaches in Texas, and she's working with a student using visual models to compose 2 and 3 digit numbers with place value. So we only have time to watch 5 minutes of this, but the purpose is to promote our discussion. No clip that anyone would ever see of any of us is perfect, right? But we want to promote discussion and develop our collective understanding about how we can support teachers to use representations that build that understanding. So as you watch the video, think about how do the representations support students in making sense of place value, and then also what feedback or coaching support might you give the teacher? Like how could we extend this or push on this? I'm gonna hit play. I just need someone to give me thumbs up or thumbs down about whether it's working and the sound. So let's try it.
100,
Oh, no. What is this?
200,
Say it again.
243.
Excellent. So what do we need?
What? That 100, 100.
Okay, that makes how much?
100.
But what do we need?
We need 4 tens this time.
Oh, but wait, how many hundreds do we have?
Oh, 200s.
So how many 100 blocks do we need to bring down?
2, of course.
Yeah, because this is only 100. We need 200. Wow, pretty cool, huh? Then what?
4 ones.
4 ones?
I mean, tens.
There you go. Count this for me. 10.
20. 40. 30.
No, count. 10, 20.
30. 40.
Now we have 40. Then what do we need?
3 ones. 3 ones.
Okay.
Ones.
1.
2. 3.
Excellent. So what do we have here? The red stand for 200 plus
4
40
plus
plus
3.
3. Yep. 200 plus 40 plus 3 equals
243. I'm just getting everything mixed up today.
excellent. What if I take away 100? What do we have left?
43.
Very good. You tell me what to take away next.
Okay. I want you to take away 1. 2 ones.
Okay. What would we have?
142.
Very good. What if I take away 2 tens? So there's 10, 20. Now what do we have?
Hey, wait. Oh, never mind. I just thought you forgot one because there's 2. You took away 2 tens and there's 2 left. So
Yep, because that would make 4, right? So what's left altogether here?
122. What if you took away the 2?
Very good.
Took away the 2 tens, it would be 100.
Then what do we have?
102.
Yeah. So how would you write that? How would you write 102?
You would write 1 and a 2.
Okay. So if I write a 1
Wait, you
and a 2, what does that make?
Oh.
Oh, that doesn't say 102, does it?
It say 102.
There you go. We have to put a 0 because how many tens do we have?
We have 2. Wait, 0 10?
0. So we have to let them know that there's 0 tens, and then we have 2 ones. Now it's 102, isn't it? But if we just put,
what if you took away the 2 ones?
let me finish though. If we just put, we have 100 and 2 ones, that doesn't make 102, does it? So that's why we have to tell them that there's 0 tens, 2 ones. Okay. So now what did you want to do?
I wanted to take away the 2 ones.
That's easy peasy. What's left?
100.
Very good. And now what?
0.
0. Okay, let's look at this number.
Oh,
All right, thanks for watching. Okay, so how did that representation support the student in making sense of place value? And then we can get to some feedback that you might give. What did you notice?
I think, sorry, God, I keep doing that, sorry. Just making it visual, and then helping them be able to see how to manipulate the numbers. And then I think it sounded a little bit more like as they started to take ownership of it and wanting to manipulate that, just their interest increased. And then they started asking questions and wondering. And that always helps kids, I think, to pay attention more so to what they're doing, and then really hook to it and walk away with a more solid understanding. So as she started to ask questions about it, then that sense making started to sound like it was falling into place.
Yes, and like you said, giving her that opportunity and that ownership, to notice not just her mistakes, but then to try some things. What if we took away this? Great. Anything else you noticed about the representation to make sense of the place value? I mean, some of them might be obvious, I guess, if you all have been working with, some of these things, but the idea that like having the number there and having the visuals, what do we need? Like, what do we need of each type? And then using that questioning to get them to get the student to think about, as you remove this, what changes about the value? And then, get them to see the value of each digit. And you probably saw at the end, that typical mistake of students say 1 and 2, because they see 100 and they see 2, but to process that place value, there's 0, 10, so that we need to have a 0 in that place. What might be some feedback or coaching support you would give to that teacher?
I might have said just to at the end when she was asking her, like, what do we have all together? And they were verbally saying 300 plus 400 plus whatever the last number was. But
yeah,
but just so they could see it. So she would have typed that out of 300 plus 40 plus 2 or 3 or whatever it was at the end, so she could see that that's what that actually is. And so that's that abstract piece of it kind of tied all together. So we had it that whole model.
I agree with that. I thought that would have been a nice addition to be able to have them see it's 200, because she was saying it out loud, 200 plus 400 or plus 40 plus 3, but to have her see that, I agree with you, because that's where we get the connection. Yep.
I think it would also have been helpful at that time to have the have the student write out the number.
Mm-hmm.
If she hadn't written anything at that point, but having her write out the number.
Mm-hmm. Yes, exactly. Have her do some of that. And maybe even show the subtraction, 243 minus 100 equals, to show like we removed it. Now this is what happens, right?
And she did it with the addition too. She would have had her write out, the 200 plus the 40 plus the 3.
Yes.
So she could see it too.
Mm-hmm. Yes, that academic ownership. Great. It's hard with limited time. It would have been nice to hear like the teacher say to the student, like, well, how did you think about it? How did you know it would be 100 too? I think it is sometimes challenging when you have the visuals on the screen, the students might, but to just hear like, what was the student thinking? Might have been nice. All right, great. Well, thanks. So to close this one out, to carry out this recommendation of using representations, we have to support teachers in choosing the right representations, connecting them. Obviously, like this is that big one. How do you use that representation to connect to the abstract, and then to revisit them, right? To continually use these and make those connections for students. So maybe they're moving to the next topic, or then, 3-digit or 2-digit division, right? And so like, how do we show these types of things in visually to return to them for students to help them make sense of that? All right, so let's summarize what we talked about in these 3 recommendations. Please read these and think about, if you were going to just pick one to take action on in the near future, which one is resonating with you? So I'll give you 1 minute to read these 3 that we talked about and think about which one is resonating with you that you might want to take action on. And then whenever you're ready, you can just type it in the chat. So 1 vote for the clear and concise language. Accurate. Oh, 2 votes for that. Yeah, that one's nice. It's almost feels like low-hanging fruit. You can implement it where you are, and it can, instantly build that conceptual understanding. Yes, push to really emphasizing that concepts. So using the language to build the concepts. All right, that's great. What else? Jennifer and Janine, any thoughts over there on which one might be resonating? Sorry, did I miss it? Oh, you're typing, sorry. Okay, so you are thinking about that. Yeah, systematic instruction. So from where students are building up to that thing that they need to know. Great. Well, thanks for sharing, everybody. Now we get to dive into fluency. And we know that well-balanced instruction, balances the pursuit of conceptual understanding, procedural fluency, and application in math. And so students have to have conceptual understanding to be able to be procedurally fluent in math. And so we want to give them activities that build procedural fluency. And so that's the last recommendation that we're going to look at today. So let's start by talking about, as you know, unfinished learning can be either of these or both of these. Students might lack prerequisite knowledge. They might have some misconceptions, or incomplete understanding of the concept itself. Or they might have unfinished learning in procedural. So they might understand the concept, but it's the procedure itself that they're not clear at, and the fluency in working together is not clear yet. So let me just give you an example. So like conceptual understanding might be, if students in 7th grade don't really understand what a ratio is, they can't really use proportional reasoning. Or if 2nd graders don't really understand that a 10 is a bundle of 10 ones, it might be hard for them in 2nd grade to write numbers in expanded form. Like they need to have that concept. Procedural unfinished learning is different in that it shouldn't halt like students' progress with instruction, right? So like if a 4th grade student is not fluent with basic multiplication facts, they just might need more time and support to understand dividing with multi-digit numbers. So kind of like we looked at in that vignette, where the student might not have the fluency with the facts, but they can build what they know and learn strategies to get there. And they can still understand this concept of division. Okay, so that's sort of the difference between conceptual unfinished learning and procedural. And so before we dive into talking about fluency, I'd love to hear your experience with fluency. Like, what would you say is fluency for students? So go ahead and type it in the chat, and type as much or as little as you want. Maybe you have lots of things that you think of as fluency. Maybe it's one specific thing, but what is fluency? You know, I think we hear it a lot in math, but I'd love to hear what you're imagining for fluency for your students. So reasonably quick and accurate with number recognition. We have some, yep, math computations, be able to recall facts quickly, readily able to solve, which is like a little different. Yeah, Tara's saying flexibly play with numbers. So understanding those landmark numbers and how they help us. So maybe also like in that vignette where the student understood 2 groups of 6 was 12. And so if we're subtracting multiple groups of 12, like to kind of have that. Okay, great. Yeah, and so I think, you know, fluency means a lot of different things to us. You know, we want students to be comfortable in solving problems and have those different strategies. So they do have to be fast and accurate, but it also can't just be memorizing, right? So let's take a look at an example. So I want you to think about how would you solve this problem? 205 minus 196. Just think about it in your head, like how would you do it? And then a thumbs up when you have an idea about how you would do it. Okay, so here's how 2 students did it. I want you to read these 2 students, and I want you to think about which student would you say is more fluent? Who is giving that procedural fluency, A or B? You can put it in the chat when you have an idea. All right, so we've got a vote for A, some more votes for A. Okay, lots of votes for A so far. Yeah, and so what would you say is the difference between these two? Like, why are we voting for A? Why are we saying this is what we hope for our students? Because student B got the right answer, but why are we hoping? Why do we hope our students are thinking in the way that A is thinking?
I think it speaks to what I put about fluency. She's able to understand landmark numbers to get quickly to a 200. Then from there, I'm able to understand what I need to do to get to the rest of the numbers. So she was essentially adding up rather than subtracting. And subtracting is where students can make more mistakes, particularly if they're not completely comfortable and they're following more of a procedure to me than understanding exactly how numbers work together and how we get to our final product.
Thanks, Tara. I would agree that, you know, this is kind of what you were thinking about with those flexible numbers. You know, and Brenda mentioned here that B has the procedure down. So sometimes when we think about fluency, at least I mean, I've done this in the past, you think about the algorithm. You're like, they got to get the algorithm. But that's not the only thing, right? A has that concept of subtraction as the distance between the numbers. So thanks for pointing that out. And thanks, Tara, for making us think about like, how do we use those landmark numbers? So I think you all really hit it here that fluency is about understanding, not just memorization. I want to acknowledge that like being able to be reasonably quick and accurate is important, right? As students progress in math, like they do have to have some fluency, but it's really about understanding, right? It's not, we don't want to rush to teach the algorithm. The idea is that it needs to be out of understanding, right? So they're attending to efficiency, flexibility, and accuracy. It's not just automaticity with basic facts. Like I wouldn't say it's not automaticity, I would say it's not just automaticity with those basic facts. And, you know, just because I would say like a student uses their fingers, it doesn't mean they're not fluent, right? So let's just keep that in mind that that's not it. And fluency is not just the ability to do it with paper and pencil. You know, it's about that idea of being able to think about the math, right? Have decision making of what is going to be the best strategy and not always be tied to that paper and pencil. Okay, I want to address something that I think we've all thought in the past, that, you know, for students who struggle with math, we might have thought it's better for them to just know one way. Like, we shouldn't teach them all these different strategies. Like, they just need to know the algorithm, or they just need to know this because it'll be easier for them. But, you know, the research tells us that every student is better off knowing a set of strategies and learning when each is and is not useful. So, you know, just to push on that, you know, it's also a matter of equity. Like, we want our students who might be struggling the most to have that opportunity to be flexible and have that understanding, the fluency understanding. So how do we do this? So there's not a magic bullet, obviously, when it comes to fluency, but again, the research highlights the approach that when we do these strategy groups, or continuing to push students on strategy rather than just basic facts, students are increasingly successful. And so if they don't know their basic facts, they probably don't have a strategy yet. So it's like the strategy needs to come before, right? Like, if a student knows their 4s, they can doubles and make the 8s, you know? So they might need a strategy versus just memorizing. So teaching these strategies is maybe already a part of your core curriculum. So maybe use number talks or other reasoning routines. Does anyone use those or have teachers that use number talks? Okay, great. So you know exactly what we're saying. And so these are really those strategy-based approaches that we want to think about also with our intervention students. Okay, so to think about this, we're going to watch a video of a math recovery specialist that's working with a 5th grade student in building their multiplication facts. So this is the 3rd lesson in a series of sessions focused with this student on the 4s facts. We don't have time to watch the whole video, so let me just give you a quick rundown. First, they start by showing the student multiples of 4s and having the student count forwards and backwards. Sometimes they have the numbers disappear to have them, you know, be thinking about it. And then in the next, then they proceed into having them covered up, so they're hidden and the student is counting forward and backward. And then finally, they're presenting the student with some dice. So this idea of, you know, supertizing, where students can look at it and say that's 4, and then how many groups of 4. So she's working with students, like, might have said, what would be before 32, and like getting them to think about that, like taking away that 4. The teacher also used end strips, so those strips of 4 dots, to help students think about groups of 4 and compose them and decompose them, and then think about that language of groups of. And the teacher would cover up some and then, you know, ask questions based on that. So that's what happened all before the video. So let's take a look at the video now. I want you to think about, how did the practice encourage the use of strategy? So giving students a strategy, and how does this compare to what you see as fluency practice in your school right now? Just give me a moment. I need to figure out how to maybe get it over here. Let's try this. Thank you for your patience. Oops. All right, I think this should work.
Look here, how many 4s do I have?
You have like the number all together, just like the block.
Yeah, how many groups of 4?
You have 28, I think.
Oh, how many groups are there? Like, so how many dice do you see?
There's 7.
There's 7. It's kind of hard to tell when they're all scattered like that, right?
Yeah.
Yeah. So what if we put them like this? There's still 7 there, right? So if I look at that one, how many 4s do I have on that top row?
You have 5 4s and then 2 on the bottom row.
You got it. So 5 groups of 4 is how many?
5 groups of 4 is 20.
Okay. And you said that I have 2 groups of 4 on the bottom row. You already told me that. How many is that down there?
That is 8. And then also since it's 7 times 4 is 28, I just thought that since there's 5 dice up there and 4, which would be 20, then when you add on the 8 down there, you would have 28, which is the answer.
You got it. See how that can help you? That's pretty cool. What if we did it this way? This way we can look at it up and down instead of the whole way. So you see doubles here. So we see double, like a double amount of 4s. So if I look at the top row here, I have 4 groups of 4, right? How many is that?
4 groups of 4 is 16.
Okay. And at the bottom, I also have how many groups of 4?
You have 4 groups of 4 is 16. And then I think I know what you could do. You could just, 16 plus 16. So you could add 10 from those 2 16s, which would be 20. And when you added 6, so take one of those 6s, add on to the 20, you'd have 26. Add 6 more, and you would have 32.
Tell me how you added those last 6. That's interesting to me.
So usually what I do when I do math is when we're adding in the 10s, I take the 2. So when I picture those 2 ones as the 10s, the 6 as the 1s. So what I do is I take those 10s, put them together, and they're 20. Take those 6s, put them together, and they're 12. And then 10 plus 12 is 32. 20 plus 12 is 32 because those 2 10s together are 20.
I got it. Okay, you are right. So altogether, we have how many groups of 4?
32.
That's our total.
Yeah.
How many groups are there? How many dice do you see?
There's just 8 dice.
Yeah, so 8 groups of 4 is 32. And we can chunk it that way. So let's look at it this way. You remember when we were thinking about our 10s? If we had all these filled and there was all 10 groups of 4, how many would I have? So if we could imagine a dice here.
You would have 40.
You got it. But now if you look at it, it really doesn't have 10, right? There's 1 missing. So how much is missing?
There's only 1 dice missing.
And 1 dice has how many dots on it?
1 dice has 4 dots.
So how can I use that to help me solve it?
You would use it to...
So if I had 40 altogether.
Yeah, so what you would do, for me, I would minus 4 from 40, which would be 36.
You got it. So altogether, how many groups of 4 did we have?
Altogether, you have 9 groups of 4.
And that's how many?
That is 36.
All right. You feel like playing a game?
All right. So after what you saw, she plays a game. They play a game to practice. Give me just a minute to readjust here.
Yeah.
All right.
Sorry.
So I'm going to get it set here. Now today,
Okay. So let's talk about that. What did you notice in the video? How did that practice session encourage the use of strategy? which we know is one of those recommendations. So get strategies in front of students so they can become more fluent. How did you see the teacher encouraging the student to use strategy?
She used lots of different strategies, but that kind of built on each other, or she was teaching her lots of different things, but like particularly in the last one, to multiply by 10 and then subtract that group of 4 to make it be 9. Times 4 is 36. And helping
using that
her
friendly number of
walk
the
through
times
that
10.
realization. And she set her up for success by asking her to imagine the 10 first.
Great. And even setting it up in that tens frame so she could see and imagine that if there were 10, 9 is 1 less than 10. Great.
I think she really spoke to organization as well, because when they started out, she had them scattered. And I think that that's sometimes what students do, is that they don't have a good conceptual understanding, which is why a lot of times we use the 10 frames to help them organize their thinking. And so when she organized her thinking, she was able to clearly see how many she had. I have a group of 5, and then I have 2 more, which is 7. And then we can move beyond that. And then we can add on, and again, be flexible with those numbers and play with it back and forth. But I have to have my organization first. So I think that's a good strategy, is helping kids get organized in their thinking.
And when you say organize, it makes me think of what you were saying with like those benchmark numbers, like knowing that a 5 is sort of that friendly number, or the 10 is a friendly number to get to. So helping them get organized in that thinking. Great. Yep. And you all probably noticed this, that she connected that tens frame with the actual words 5 groups of 4 and 2 groups of 4, 20 plus 8, right? Like she was showing them all at once to make that connection. And how would you say this this compares to some fluency practice that you do at your school? Do teachers have an opportunity to work with things like work with fluency in this way, or are there other ways that they do it right now? Are there ways that they think about fluency? Or maybe both. Maybe they do this and they think about it in some other ways too.
I was just going to say, we use number talks. That's how we open up all of our lessons each day. And I was trying to think about the number talks and the progression of it. And I think they go, I was just kind of thinking about those numbers, like we use the subitizing, but I have the 10 frame with those 4s. Like I thought that was like, oh, that's a great way to show that. And I don't believe it shows it like that. I think it kind of goes from subitizing to just having the numbers and, kind of saying like 7 plus 5, what strategy did you use? And they're supposed to kind of just talk about it in their head and be able to communicate that. And I was thinking like, oh my gosh, if kids could even draw this and show that, like that's a way of, they're thinking as well. Because sometimes they can't always produce the words just like adults. Like when I have to explain something, like they could draw it, and then their drawing can hopefully maybe help teachers understand what they're thinking too. So I really liked that. And I was like, oh, that's just one thing we can add in there that we're already doing. That's a really easy, like, oh, hey, look what we learned today, and something I can bring back to our staff.
Great. That's great. Yeah, the idea, I'm imagining even just like having that 10 stream on the board. And if the students are talking about 7 plus 5, you can show them how, okay, let's plug 3 in here to make a 10. And there's these 2, so we've got a 10 and 2. Great. That's great. Well, I like hearing about the number talks. I will confess that when I was growing up and then when I was teaching middle school, sometimes I did a lot of worksheets and drills. And I think those have some place like for a little bit of fun. But this just can't be the only thing for fluency, right? Because fluency is not just the drill and the kill, right? It's really about getting the students to think about the math flexibly, as you all have said. And so, examples of this are fluency routines, worked examples, games. Like we didn't see it at the end, but just having play tic-tac-toe to get them to understand like their facts. It's motivating. Independent practice, those taped recordings, and obviously these number talks, like these are other ways to get fluency and strategy in front of students rather than just giving a worksheet. On page 14, there are some recommendations and tips for carrying out fluency, and there's some resources on page 14 if you want to check those out after the session. So the big summary here is, I think we're all on board here that it's more than just basic facts. Like we want them to be quick and accurate and be able to eventually do the algorithms, but we want them to understand strategies, right? And all students need high quality fluency instruction and practice. So not just students in the main classroom who are doing number talks, we need to implement this in intervention too. All right, so as we wrap up today, I want us to think about of those four, and you kind of mentioned this earlier, but of those four recommendations, is there something, a bite-sized action that you want to implement? You know, like I know Janine mentioned something, adding those 10 frames in, adding that representation could be something for a strategy, but is there a bite-sized action that you want to take based on today's sessions and looking at those strategies? So let's take 2 minutes. You can just kind of jot those down for yourselves. And then after those 2 minutes, I want to spend the last couple minutes just wrapping up our 4 sessions. All right, so I hope you're able to find something today that you found useful and maybe a bite-sized action that you can come up with to implement one of these recommendations in the coming weeks. So now let's shift our focus for the last couple minutes here on just kind of summarizing where we've been. It felt like through the last couple months, you all were really excited about this idea of accelerating student learning. In our first session, we defined the approach to addressing unfinished learning, so this acceleration idea. In our second session, we talked about how to assess and diagnose that. So how do we understand the standards? How do we backwards plan? And then how do we find those small assessments to give students? And then in session 3, our last session, we talked about how do we use that evidence from those assessments to then plan to implement. We noticed that there were some ways to implement in whole group instruction. And I know Brenda shared the example of implementing that into the warm-up. And then even the small group instruction. And then today we talked about students that might need more than that tier 1 instruction and those tier 1 acceleration supports. So I guess the question is like, where do we go from here? And it breaks my heart we don't have more time, but I hope you have a minute to think about that, and remember big doors swing on small hinges. So like, what are those things, those small things that you want to commit to doing, or maybe big things, maybe you're dreaming big for next year. As you think about the work we've done together in these 4 sessions, like what is that that you want to work on so that we can, make an impact on student learning in your school?
One thing that we've talked a lot about is going back to the videotaped sessions of the work that we've been able to do together, and really putting together a plan for which pieces do we want to revisit with our grade level leaders as we think about the way that our PLCs will look next year, and really spending some time this summer with them, doing some of the work that we've been able to do as a group here, and digging into and helping them to see how to look at the previous grade level standards, or how to really understand the standards that their grade level is working on, and then go back and look at the grade level before them, and just I guess training them up so that they can help lead to some of those discussions with their grade level teams next year, and asking them to help us look at the calendar and just do some of this work together with our grade level leaders, so that we have some of that buy-in from the staff. And then we are really lucky because we have like additional PD days at the beginning of the school year. And so we'll be able to do some of that work with teachers, but then like we were just talking today about looking with teachers at that math block, and the pacing guide, and thinking about like what strategies will we be teaching naturally anyway, like when do we teach make a 10, when do we teach adding on 1, 2, and 3 in those primary grades, and really blocking out some time so that we are strategically teaching those that fact fluency, and giving kids an opportunity to talk out loud about those things as we do the number talks anyway, and then giving them time to practice using some of the resources that you suggested, along with some that we already have, but really using that time intentionally so that teachers have a plan, and that we have a school-wide expectation for what that will look like, so that kids just that's just the way we do things, and then kids are, that automaticity comes, and that flexibility and thinking, like Tara said, comes with that.
Great. Thanks for sharing.